Hey everyone, today we're going to talk about compound interest because compound interest can either ruin your life or make you rich. We're going to cover what compound interest is and why it matters, go through a quick mathematical example of how it works, and then I'm going to touch on something called effective annual rate so that you never get screwed over by a lender again. In order to understand compound interest, we first have to understand simple interest. So what's the difference? Simple interest is interest that is calculated on the principal amount only. So it's consistent every single month because it's only being calculated on one single number. Compound interest, however, is interest that is calculated on the principal amount as well as any interest that could have already accumulated. And because of this, it grows exponentially. And when you plot simple interest and compound interest on a graph, this is what you get. So you can already see the power of compound interest compared to simple interest. Why does compound interest matter? Well, if you're deep in debt, compound interest matters because it can really shackle you for the rest of your life. Compound interest can shatter your dreams of your ideal future, the type of lifestyle that you can afford, or even prevent you from reaching common milestones such as home ownership or starting a family. Although when we're talking about debt, compound interest can be a very malicious mechanism, it also happens to be one of the key ingredients in long-term wealth building and financial freedom. Compound interest can unlock the possibility of experiencing things that you've always wanted out of life, retiring early, and gaining full control of your time and ultimately achieving freedom. So let's go through a quick mathematical example to really deeply understand how compound interest works. As a quick recap, again, the difference between simple interest and compound interest is that simple interest is calculated on the principal amount only and is linear, whereas compound interest is interest that is calculated on principal and interest, and because of that, it grows exponentially. Quickly applying simple interest, let's do an example. Let's say that you borrow $10,000 from a friend at an annual interest rate of 5%. And your friend says that you could pay me back in 4 years. How much would you owe that friend after 4 years? Well, in this example, our principal amount is $10,000. Our annual interest rate is a simple interest rate of 5%. And we can build out this quick table to calculate how much we'll owe our friend at the end of every year. At the end of year one, our 5% annual interest rate is applied to our principal amount of $10,000. 5% of $10,000 is $500, so our balance at the end of year one is $10,500. At the end of year two, once again, our interest is applied to $10,000, so once again, we earn $500 of interest. Now we add that $500 to the balance that we had at the end of the previous year, which brings us up to $11,000. If we continue this pattern for the next couple of years, we will eventually end up with $12,000 of debt to our friend. This is the formula for simple interest. A equals P, 1 plus RT. A represents the final amount, P is the principal amount, R is the interest rate over a given time period, and T is the number of time periods. So if we were to redo this example using the formula method, plug in all of our variables, we would also end up with $12,000, just as we did in our table example. Now let's take a look at the same problem, but applying compound interest. This time your friend once again lends you $10,000, but now it's at an annual compound interest rate of 5%. How much would you owe him after 4 years this time? Well, if we set up our table once again, our principal amount is the same as in the last question, $10,000. Our annual interest rate is 5%, but it's being compounded annually. If we set up our table, once again, in year one, the amount that the interest is being applied to is our principal amount, $10,000. 5% of $10,000 is $500. So now our balance is $10,500. But now at the end of year two, we're applying our interest to the principal amount plus any previously accrued interest. Therefore, we are applying the interest to that final balance of the previous year of $10,500. And now 5% of $10,500 is no longer $500, it's $525. And when we add this up, we're now just over 11 grand in debt to our friend. Now in the third year, we're again applying our 5% interest to the balance of the previous year, $11,025. 5% of that is $551, and so the pattern continues. And in this example now, at the end of those 4 years, we'll have owed our friend $12,155. This is the formula for compound interest. A equals P1 plus R over N to the power of NT, where A is the final amount, P is the principal amount, R is interest rate over a given time period, T is the number of time periods, and N is the number of times that the interest is applied or compounded in a given time period. So in this case, our P was once again $10,000, our R was 5%, T was 4 years, N was 1, because the question specifically stated that this 5% rate is an annual rate, meaning that it accumulates only once annually or once every year. And plugging in those variables, we once again end up with the same amount of $12,155 that we ended up with in the table. If we compare this to the result that we got in our previous example, this is $155 more than the $12,000 that we owed our friend when we applied simple interest. So the key takeaway here is that what matters most when talking about compound interest is, first of all, your principal amount, and secondly, the time that compound interest has to accumulate. So what if you invested that $10,000 instead? Let's say that you held on to it for 25 years, you invested it. At the end of those 25 years, you would have ended up with just over almost $34,000. If we plot this investment on a graph and compare it to a simple growth versus the 5% compounded annually, we would see that the difference is $23,864, which is pretty amazing for doing no work. Your money more than tripled in 25 years and you didn't have to really do anything. And that is exactly why Albert Einstein was quoted as saying that compound interest is the 8th wonder of the world. He who understands it, earns it. He who doesn't, pays it. So now let's talk about a quick concept called effective annual rate. The calculation for effective annual rate is essentially a conversion. You may have seen different wording for compounding. If you compare the term 8% compounded annually to 8% compounded quarterly, or perhaps 11.5% compounded monthly, or 2.66% compounded daily, of course, these terms should not simply be ignored. This is the formula for effective annual rate. Effective annual rate equals 1 plus I over M to the power of M minus 1, where effective annual rate is a percentage, like any interest rate. I is an interest rate over a given time period that you know, and M is the number of compounding periods that you know based on the language that's in the question or in the terms of your debt agreement. When we're talking about compounding quarterly, M is 4 because there's 4 quarters in 1 year. Monthly, M is 12 months in a year, and daily, you guessed it, M is 365 because there's 365 days in the year. This is a handy little chart summarizing the wording and the number of compounding periods that wording refers to. It's good to reference this if you're ever confused about the wording. Let's do a quick example. What is the effective annual interest rate corresponding to a rate of 12% compounding quarterly? So this question is asking us to convert 12% compounding quarterly into a rate that's compounding annually. Of course, this is the formula for effective annual rate. And in this question, I is 12%, that 12% that's given to us in the question. M is 4 because the question indicates that it's compounding quarterly. And when we plug in the numbers, our effective annual rate turns out to be around 12.551%. which is approximately 12.6%. Now, if we were to take this 12.6% compounded annually and extrapolate it to the next 25 years, this is the graph that we end up with when we compare 12% compounding annually versus 12.6% compounding annually, which is actually 12% compounding quarterly. Our $10,000 principal amount grew to $170,000 when 12% was compounding annually versus $192,186 when we were talking about 12% compounding quarterly. That's a difference of $22,000, which is quite a difference for just one change of wording in a question or in the terms of your agreement. Given what you know about compounding interest and the importance of the principal amount and time, imagine how much your money could grow if you gradually increased your nest egg over time. This is a calculation that you can do on this compound interest calculator that will take into account the time that you plan to invest, your principal amount, and any other contributions that you plan to make into your principal amount. It's pretty fun to play around with. I'll leave a link down below. I hope that this quick educational video was a good refresher or lesson about compound interest. I encourage you to leverage the power of compound interest starting as soon as possible. If you enjoyed this video or found it helpful, consider subscribing. And until my next video, bye.